Let's go to page 243, and let's do number 379. Okay, so 379, you have the tetrahedron ABCD. Okay, so let's go and draw that. Okay, so you got A, B, C, D. And the 6 edges are measure 7, 13, 18, 27, 36, and 41. Okay, if the length of edge AB is 41, then you're looking for CD. Okay. So you have to use the inequality theorem. So if, look at this triangle over here. So if the AB is 41, then you cannot have the 7 and 13. Okay, you cannot have any combination of those two, because if even you have 13 and 18, you're going to come up with only 31. So it's going to, again, the inequality theorem says that the sum of two sides have to be greater than the other side. Okay. So even with the 20, so if you get, so you can even have a 27. Okay, because 27, if the other two sides 27 and 18, we only give you, well, so this would be fine. Okay, so that means, so by looking at that, you know that one of the sides had to be a 36 and so one of these had to be 36 and 27. So let's go and put a 36 over here and 27 over here. Okay. So again, you need to have one of these on each side. Okay, or else it's not going to work. Okay? You cannot have any of these numbers on these two sides. Okay, so it means one of the sides has to be 36 and 27 in order to stretch long enough for the 41. Okay. So that takes care of this over here. Okay. And again, by process of elimination, let's do this one over here. Okay, so you cannot have a 7 over here. Okay, because 7 and 27 only give you 34. So 7 cannot be over here. Okay. And 7 cannot be over here because 7 and 27 only give you 34, does not give you 36. So 7 cannot be here or here, so 7 has to be over here. Okay. And you do the same thing with the 13. Okay. So 13 cannot be over here because 13 over here only give you 40, so it's not going to be enough to cover the 41. So 13 would have to be over here, and 18 had to be over here, and therefore answer would be 13. Okay. But again, you just have to using the process of elimination. Okay. So let's go to the next one. So the picture is giving. So this is A, B, C, and this is P, and this is O. Okay, so first, the giving is the radius is 20. So this is 20. Now let's go and draw. Since this is the inscribed circle, okay, so all this will be angle bisected because equilateral triangle. Nice thing about equilateral triangle is that when you cut through this, okay, this is the angle bisected, but it's also the median. So when it's median, you would divide it into the ratio of 1 to 2. Okay, so if this is 20, this would be a 40, And if this is 20, so you can see that this dividing into 20, 20, 20. Okay, so you can radius is 20, so this is 20 and this is 20. And if this is 20, okay, again the median we divide this into ratio 1 to 2. So if this is 20, this would be a 40. So therefore, this is also 20. Okay. So what you want to do is just go and use a scale factor. So scale factor is equal to 1/3 because this is 20 and this is 60. So it's 1 to 3. Therefore, the radius would be 1 to 3. So small r will equal to 1/3 of the big R. Okay, and so r equal to 20/3. So this is the quick way of doing using the scale factor. Now another way to do it, since all these are 30-60 spatial triangle, you just have to kind of go and figure each part. Just kind of move up and eventually get that part. Okay. Again, there are many ways you can do this. You can also using the similar triangle. Okay. Again, you can draw that and you can use, once you figure all the parts, you can using the similar triangle also. But a quick way to do it, just go and use the scale factor. Okay, that's the fastest way. Okay, let's go to the next one. Okay, so 381, a hexagon is inside a circle of radius r. Okay, and you want to looking for the radius r. If two sides of the hexagons are 7 and the other 4 sides are 20. Now, nice thing about this is that you can move the short side around so that you can always form some kind of symmetry. Okay. So again, this is not a regular hexagon. So I'm going to make this is 20, 20, and this is 7, 7, 20, 20. Okay. Again, it doesn't matter how you rotate, it will not affect the radius. So for example, like if you were to switch these two, okay, you can, so instead of 7 and 20, you can make this into 7 and make this into 20. It will not affect, you see how this thing, so you can switch it around, it will not affect this line over here. Okay. Okay, but it will make things easier to calculate if you make this over here so you have some kind of symmetry. Okay, okay, so you can go and draw these things down. So the triangle is kind of a little bit off. Okay, so let's go and label things over here. Okay, so again, this is not to scale, right? This is 7, this is 20. Okay, so if this is 7, here you go across, and this is a radius, so this would be 7/2. This would be 7/2, and it would be r. And so again, this is also r up here. So this is going to be r minus 7/2, and let's go and call this x. Okay. So now we're going to write the Pythagorean theorem for the two triangles because we got two variables. We need to have two equations. So for this triangle, we have the r minus 7/2 squared plus the x squared equal to 20 squared. For the lower triangle, we got 7/2 squared plus x squared equal to r squared. Right, again, I'm just using Pythagorean theorem for this triangle, Then you go and work it out. So you got r squared minus 7r plus 49/4 plus x squared equal to 400. This one over here, I get 49/4 plus x squared equal to r squared. Right, if you notice over here, see this over here, you got two of the same expression. So this is equal to r squared, right? So this is equal to, so you can substitute this into here. So this is your r squared right over here. Okay, so let's go and solve this. So you got 2r squared minus 7r minus 400 equal to 0. And then you can go and do the factoring. So you're going to get negative 7 and negative 800. Okay, so again, you start with 1 comma, negative 800, 2 comma, negative 400, 3 cannot, so 4, negative 200, 5, negative 160, 8. So once you get 8, notice that you have to use this over here, so this would be minus 100. And none of the multiple 3 is going to work. Okay, so 9, 10. So use this over here, so it would be negative 80. Okay, and so 12, 11, 12, 13, 14, 15. 15 cannot. Okay, so 16. So use this one over here. So this is twice as that, so this will be half. Okay, 17, 18, 19, 20. I can use this over here, so it would be minus 40. And then 21, 22, 23, 24, 25. So this is 5 times that, so this would be 1/5 of that, so it would be minus 32. And this one works. Okay. Okay, so you got r, 2r. So this would be the inside, so minus 16. This would be the outside, so plus 25. So from here, you're going to get r equal to 16, r equal to negative 25 over 2. So this is it. Okay, okay, let's go to 382. Okay, 382, the picture is giving, so it's kind of nice. Okay, so you have the A, B, C, you have the P, you have the M, you have the O, and you have the D. Okay. So you try to look for the AP times AM is equal to what? Okay, so the way to do this problem is you go and use a similar triangle. Okay, now, since this is a diameter, this would be a right angle, right? Because if this is a diameter, this is 180. If this is 180, this is 90. Now, once you have a right triangle, when you draw any line that's perpendicular or parallel to any side, then the triangle that is formed would be similar triangles. So the small triangle would be similar to large triangle. So what you want to do is you want to use a similar triangle. Okay, so triangle APO is similar to triangle ABM. So use a similar triangle, so you're going to have an AP over AO equal to AB over AM. Right? AP, so hypotenuse over long leg equal to hypotenuse over long leg. Then after you cross multiply, so you got AP times AM equal to AO times AB. Okay, and that's it. Okay, let's go to the next one. Okay, so you have a triangle A, B, C, D, E, and the G over here. Okay. So you can triangle ABC. Okay, D is the midpoint of BC. So that's a congruent. E is the midpoint of AC, so these two are congruent. Okay, and if AD equal to 6, now realize this. If this is the midpoint, this means this is the median and this is the median. So when you have the median, then all three median will meet in one point, and that's the center of gravity, so that's G. Okay. And so the median would divide into a ratio of 1 to 2. Okay. So if AD equal to 6, then that means this would be 2 and a 4, because ratio of 1 to 2. Okay, again, that's the median. Okay, and BE equal to 9. Okay, so BE equal to 9, so they divide into 3 and 6. Okay, and AC equal to 10. So if this is 10 and this is the midpoint, so this would be a 5 and a 5. Now if you have 3, 4, 5, then this is a right angle, okay? And vertical angles are congruent, so this would be the right triangle. Okay, so let's go and figure out the areas, okay? So the area, let's do the AGE. So this triangle over here would be easy, it would be 1/2 base times height. Okay, again, we're looking at this triangle over here. So the area of AGE equal to 6. So I'm going to put 6 in here and circle that. Okay. Next is I'm going to turn this sideways and look at this triangle over here. Okay, so since the base are the same, right, it's a midpoint, so the base are the same and the altitude are the same because it's from the same point. So you have the same altitude. So if you have the same altitude, same base, you're going to have the same area. So this area of 6. Okay. Now I'm going to come over here, I'm going to do the same thing over here. I'm going to figure out the area of BGD. Okay, so area BGD is 1/2 base times height. So area of BGD equal to 6. So I'm going to put 6 over here and circle that. So the circle numbers are areas. Okay, so can you turn this triangle this way? Again, same thing. If you look at this way, so look at this triangle now. Okay, since this is the midpoint, so the base are equal, right? They're congruent. And since it's the same point, the vertex is the same, so they have the same height. So you have the same height, same base, you're going to have same area. Okay, so this would be also 6 over here. Now I'm going to come over to do this area over here for the area of ABG. Okay, so this triangle over here is a right triangle, so it would be 1/2 the base times the height. So area of ABG equal to 12. So this is 12 over here. Okay. So what actually happened is when you have the medians will cut this into 6 equal area triangles. So you're gonna have each of the area is 6. Now because this one is 12 because it's 2 triangles, right? 2 small triangles. Okay. And you're gonna realize that this will also be the midpoint. Okay. Because that's what the median would do. Okay, all 3 medians will meet in one point. Okay, so when you draw this line through this point over here, okay, it will reach the midpoint over here. But anyway, so the total area, you just add all this together. Okay, so it'd be 6. So this will be 12, 12, 12. It give you 36. Okay, let's go to the next one. Okay, so the picture is giving. Okay, so that's your X, Y, C, D, A, B, and it's L, M, N. Okay, and we have the F over here, G over here, and H over here. Okay, so there's a whole bunch of things we have to prove. So first, let's go ahead and use the similar triangle. So look at it. So this is we're going to call it small, medium, and large. So we're going to use the similar triangle for the small and the medium. Okay, so you got x over, so you have the left side of the left side, okay, equal to the right side of the right side. So you're using similar triangle, so small over medium equal to small over medium. And I'm going to cross multiply and I'm going to move things around. So move these things down, move this up. So you got x over y equal to x plus c over y plus d. Okay. Now, according to proportional theorem, okay, once you have the equation, you can add and subtract any part, the corresponding part. So in other words, if you have this, you can add the x onto here, you can add y onto here, or subtract. Okay. So I'm going to use the same equation. Now, what I'm going to do is, I'm going to add this part onto here. I'm subtract this into here. So minus x minus y. Okay, so do this. And so I get x over y equal to c over d. Okay, so that's the first one we need to prove. The next one, okay, we're going to continue with this. Okay, so you got x over y equal to c over d. So you need to start with your equation. Okay. And so now I establish that I can use this over this equal to this over that. Okay. So just by that analogy, then this equal to this over this, then this will also equal to this over this. So this will equal to x plus c plus a over y plus d plus b. So you can just using an analogy, right? So you have the left over right equal to the left over right equal to the left over right. So that's where I get it from. Okay, now again, you can add and subtract anything on the same side, okay, on the either the top or the bottom, right? So you can subtract anything on the top, you can subtract or add anything on the bottom. So what I'm going to do is, since this over here, I'm going to put this down here, okay? So I'm going to minus the x plus c, and I'm going to minus the y plus d, because they are equal, right? You see this over here, right? So you need to have the equation first. You need to have the proportion first before you can do that, okay? So you can, because these are equal, okay? So I can, and these are equal, so I can add this onto the top, add this onto the bottom, or subtract it from the top, subtract it from the bottom. Okay. And so from here, so I got c over d equal to, I'm just line it up, and this one, all this will cancel out. Okay, so it's set for a over b. Okay, and that's it for that part. Okay, now let's go and do the next part. Okay, so next part I'm going to, again, using similar triangle, I'm going to use the bottom over right equal to bottom over right equal to bottom over right. Okay, so, and using the three triangles. So I have the bottom over right equal to the bottom over right equal to the bottom over right. So again, I need to get my proportion first before I can add or subtract anything, right? So this is a small triangle, medium triangle, large triangle. So I get the bottom over right side equal to bottom over right side equal to bottom over right side. So small triangle, medium triangle, large triangle. Okay. So once I get my equation, then I can go and use the proportion theorem. Okay. So I'm going to use. So I'm going to start over here. Okay. Again, now I can use any combination, right? So now I'm going to use this minus that. So I'm going to use these two over here. So I'm going to use this minus that. So I get. So I'm going to use this minus that. So it'd be g minus f. Okay. So again, once I establish my equation, I can do any combination. So I can use this minus that over this minus that, and it will still equal. Okay. And so f over y will equal to g minus f over d. Okay. Now I'm going to do the same thing. I'm going to use this tool now. Okay. So again, I'm going to have a f over y. Okay. So I'm keep one of the fraction, and I'm going to have h minus g. So I'm going to use this minus that. So that means on the bottom, I need to use this minus that. So I get b plus d plus y minus d plus y. So I get f over y equal to h minus g over, okay, so a bunch of stuff going to cancel out, so I get over b. Okay, now notice this is equal to f over y, this is equal to f over y, so this is going to be equal to each other. So g minus f over d will equal to h minus g over b. Okay, and that's the last one we need to prove. Okay, let's go to the next one. Okay, so go and read through and go and draw the picture. Okay, so I get A, B, C, D. And these are the right angle trapezoid, so that's kind of nice. And M is a midpoint of AD. Oh wait, I have this backward. This is B, and this is D. Okay, so M is the midpoint of AD. And we have BC is equal to AB plus CD. So we use that later. And S be a point on the BC such that CS equal to CD. Okay. So S be a point on the BC such that CS is congruent to CD. Okay, so you want to prove that angle ASD is a right angle. And then second, you want to prove that angle MDS equal to angle MSD. Okay, so let's go and draw extra lines over here. Okay, so this is the midpoint, so we know that this will be congruent, right? Okay. Okay, so first let's let the angle BSA equal to X. Okay, what else do we know? 385.
Seventh and eighth graders, if you have your Royal Snack coupon, you may go to the snack bar and get your treat. Again, if you have your Royal Snack coupon, please go to the snack bar to get your treat. Mahalo.
Okay, so let's go and call this X. And let's go and call this Y. Now since this by isosceles triangle theorem, so if this were congruent, then this had to be congruent. So this would be a Y. Okay. And what else do we know? Okay, AB plus CD. So BC equal to AB plus CD. Oh, okay. So from here, so since these two are congruent, so if you notice this over here, so this would be congruent based on these, right? Okay. Because these two are congruent, so this is equal to this plus this. So this match with this, so this has to match with that. So from here, so from this part over here, we can see that that this will be congruent to that. Okay. So again, from these, we can see that SB is equal to AB. Okay. So from here, if this is X, this would be also X, right? By isosceles triangle theorem. Okay, so from here, and then we can figure out each of these angles. This would be 180 minus 2y. This would be 180 minus 2x. Right, because sum of the three angles have to equal to 180. So now what we're going to do is we're going to look at this linear angle over here. So you got angle BSA plus angle ASD plus angle DSC equal to 180, right? So the three angles will add up equal to 180, okay? And also, we can see that another thing we can notice is that angle B and angle C equal to 180 because they are same side angle. They are same side angle equal to 180. Okay, so what we're going to do is we're going to kind of substitute this into here. Okay, so we're going to substitute this into here. Okay, before we do this. Okay, so from here, so this equation over here, we get angle B is 180 minus 2x. Angle C is 180 minus 2y, and this is equal to 180. Okay, again, we're using the same side angle. Same side angle equal to 180. Okay, then you can work it out. So you got 180 minus 2x minus 2y equal to 0, right? 180 cancel out, right? And moreover, so 180 equal to 2x plus 2y. Divide by 2, so you got 90 equal to x plus y. Okay. So now once you got x equal to x plus y, now we can go ahead and substitute this into here. Okay, so let's go and do that. Okay, so BSA is x. And DSC is y. Okay, so we use this equation over here. So we got angle ASD plus, well, x plus y from here is 90 degrees. Okay, let's put the degrees in here to be more exact. Okay, so angle ASD equal to 90 degrees. And therefore, angle ASD is a right triangle. It's a right angle. Okay? So we prove that. That's the first part. Okay, so next thing we need to do is, so now we know that this is a right angle. Okay? So the next thing we need to prove is this part over here. So I'm going to do over here because we need to look at this picture. Okay. So M is the midpoint of hypotenuse. Because notice that this is a right angle, so this is a right triangle, and this is the midpoint of a hypotenuse. Okay. So therefore, MA is MA is congruent to MS is congruent to MD. Okay. So all this would be congruent, okay? Because again, according to the theorem, right? Now, once you do that, once they're all congruent, then you can see that this angle is congruent to this angle. Okay, so you can see that angle MDS is congruent to it's equal. I'm going to just go equal. Okay, let's do congruent. It's congruent to angle MSD, and the reason for that is that the angles facing congruent sides are congruent, right? This is the isosceles triangle theorem. And then we can use a definition of congruent angles. You got angle MDS is equal to angle MSD. And this is the definition of the congruence, right? Okay, because if they're congruent, they are equal. Okay. Okay, let's go to the next one. Okay, so let's go ahead and draw the picture. Okay, so let BC of the right triangle ABC be the diameter of the circle intersecting the hypotenuse AB at D, and the tangent is drawn cutting the CA at F. Okay, prove each of the following. Okay, so we have all those stuff. Okay, but anyway, so first let's go ahead and draw this right over here. Okay, now since this is the diameter, then this would be a right angle. Okay. And again, I'm going to let this equal to x and call this y. So from this picture, we can see that the x plus y equal to 90 degrees, right? Complementary angles. And by looking at, now if you look at this triangle over here, right? Okay. So again, x plus y equal to 90, and therefore this must be also a y. Okay, because x plus y equal to 90, so if this is x, this must be y. Another reason this is equal to y is because, remember, when you have a right triangle, any perpendicular line or parallel line will make all the triangles similar. So the small triangle would be similar to big triangle. So if this is x, it's similar to itself, so the y was similar to this. So this would be matching angles. Okay, so again, you can either use a similar triangle, or you can use the algebra method. Okay, so angle A equal to y. Okay, and so from here, so right away, you can see that this is y, this is y. So angle A is equal to angle BCD. Okay, so this is the number 3. Okay, so this is the number 3 you need to prove. Okay, so and from here also that the angle BCD equal to y and angle DCF equal to x. So we just kind of let equal to that. Okay, and next is that we have DF equal to CF. So we have this equal congruent to that, and the reason is because both are they are tangent to the common points. So tangents to a common point are congruent. Okay. So again, this is a common point. Those are two are tangents, so these are congruent. And now you have therefore you're going to have angle CDF is equal to angle DFC. Okay, so angle to CDF equal CDF will equal to DFC. Okay, and the reason for that is because you are using the isosceles triangle theorem, right? Okay. Now you also look at this triangle right over here. Look at this angle right over here, right? X plus y equal to 90, and if this is y, this has to be x over here because x plus y equal to 90. So from here you can get that, right? X plus y equal to 90. So if this is y, this has to be x, and therefore this will also equal to x, okay? Because they are facing the congruent sides. And by doing that, again, this is also a right angle. So therefore, since this is x, so from the y you get the x. From this x you get this x. From here you can get that this is a y. Okay. So therefore, angle ADF equal to y. Again, from this right over here. Okay. Okay. And then we can see that, so next one is AF equal to DF. So AF will equal to DF because they are facing the congruent angles. And so this is your second one. Okay, that's your second thing you have to prove. Okay. And wait, what's the first one? Oh, okay. So then DF bisects CA. So once you find that they are congruent, okay, CF from here, CF equal to DF. Okay, then and also now if you look over here, now by looking at the marking, right? So we can see these and these two over here. Okay. So they're all congruent. Therefore, from these two over here, so AF equal to DF and DF equal to CF. So therefore, from here you can see that CF is equal to AF. Okay, from these two over here. Right. So that's your transitive. And so therefore, so CF equal to AF. So F is the midpoint. Okay. Okay, so therefore, DF bisects CA. Okay, and this is the first one. So this is the first one. Okay. And then after that, we need to keep going. So from here, you can see the angle CFD. So CFD, we're going to use exterior angle theorem. Okay, so since this is y, so this would be a 2y. Okay. So angle CFD equal to 2y. This is your exterior angle theorem. Okay. And therefore angle CFD equal to 2a, 2 times angle A. Okay. And you can just see that. So this is the exterior angle theorem. Okay. And so that's it. So this is the fourth one. Okay. So this is the exterior angle theorem. Exterior angle theorem.